Hey everyone, it's John, and today we're going to continue back in the CCNP based switched video series, and in this video what we're going to be doing is looking at private VLANs. Now first things first, quick apology, I haven't really been uploading, that's because I've been doing exams, but now they're over with thankfully, and I intend to get the rest of this series done pretty quickly and then move on to some other stuff. Okay doke, so with that said, let's go and do it. So the first question, what actually are private VLANs? Well, effectively, private VLANs allow you to separate traffic from within the same VLAN, okay? And it's commonly seen in the service provider world as well as in like demilitarized zones, DMZs and stuff like that. So the plan for this video is to give a quick overview of what they do, the different modes in which you can get for private VLANs, and then do some basic configurations and then wrap it up. Okie doke. So with that said, let's go and do it. Now, when you ask the question, why configure private VLANs, and I give you the answer, well, it allows you to separate traffic from within a VLAN. Logically, you might follow up with the corollary question, why not just use more VLANs? Well, that is a perfectly reasonable response. But here's a little bit of a thing to consider. When you make a VLAN, what do you tend to do? You tend to have this. A VLAN equals a subnet. Right? So in the example which I've got here, we are running all this within VLAN 100, okay? But let's say we wanted to have traffic separation between the devices within this VLAN 100, so we decided to introduce two VLANs. So let's say we make these ones in VLAN 100, okay? And we say, you know what, we're going to introduce a secondary VLAN, we'll make this VLAN 200 instead. That's how we'll get our isolation. Well, typically, what you're going to do, and I've kept the addressing really simple here, and this would probably be public IP addressing, but I've just used private to keep it basic for understanding. So VLAN 10, you're going to be using maybe 192.168 of 100, that should be rather. Apologies there. And VLAN 200, you're going to use this new address space. Now, you can subnet this out and make it a little bit more efficient, but the point remains is that you're going to be using up more address space. Now with private VLANs, it gives you that kind of elegant solution to solve this problem by keeping the address space the exact same, in this case 192.168.100.0, and you can allow this traffic separation at layer 2, which you're aiming for by otherwise introducing more VLANs, okay? So that's pretty much, that's the real kind of common rationale behind using private VLANs. So question is, how exactly does this work? Well, let's discuss it. There are two main things to consider. The first is the type of VLAN which you have. Now, the first VLAN in the private VLAN is the primary, okay? That is the main VLAN. If you look back at the graphic here, you'll see that we've got VLAN 100. All these devices are within VLAN 100, and VLAN 100 is considered the primary VLAN. It kind of acts like the parent, okay? And the sub VLANs, effectively, these private VLANs within that VLAN are going to be a part of VLAN 100 and have to be mapped to it, okay? Now, the private VLANs within the main VLAN are just secondary VLANs, okay? And these VLANs come in different modes, okay? So when you're configuring your ports, you're going to be telling the VLAN how it's going to behave, the private VLAN how it's going to behave. Now the first one is a promiscuous port, okay? And what a promiscuous port can do is it can effectively talk to everything, okay? Think of the name promiscuous, it goes everywhere, it can talk to anyone. There is no limitations in what the promiscuous port can do, okay? The second one is an isolated port, okay? So if you put a port into an isolated private VLAN, what it means is that it can only talk to the promiscuous ports. It cannot talk to any other devices, including devices within the same isolated VLAN. It gives almost perfect isolation. All it can do is talk to, maybe say, the gateway. If you make the gateway promiscuous, it can go out and talk to the internet, but it can't talk to any other devices attached to the switch, okay? Now, third one is the community private VLAN. Now, what this does, it allows you to group together devices or ports within a private VLAN so that they can communicate to each other as long as they're in the same community, but they cannot communicate with devices in a different community, okay? Now this might be a little bit confusing, but just stick with it. I'll do a little bit of a diagram and demonstration just to maybe perhaps highlight this a bit better. So let's say we've got a router here, okay? And let's say we're connecting down here to a switch, okay? And we've got some devices here. So let's say we've got a device here, one here. This drawing isn't exactly Picasso, is it? Okay, so we've got a couple of devices. Now let's say that we've got VLAN 100, okay? This is all within VLAN 100. This is the primary VLAN, okay? It's all within VLAN 100. But we're going to subdivide that VLAN into smaller private VLANs. Now let's say we make these two devices here in VLAN 105, and we make that a community VLAN, okay? And we make the devices here in a different VLAN, call it community, it can be 109, VLAN 109, it's a community as well. And let's say, in fact, you know what, I'll add in another port just so you can just emphasize this bit. And then we add in a final private VLAN here, and we call this VLAN 150, and we make this one isolated. Okay, so what can talk to what, okay? So the first thing which we're going to do is see, because we want everything to be able to talk to the router, we're going to make this port here promiscuous, okay? That means it can talk to everything. Okay? Now, within VLAN 100, we've got these three different VLANs. We've got VLAN 150, 109, and 105. Devices within 105, down the left here, okay? They are within the same community, so that means this device here can talk to this device here, okay? No problem. And it can talk to the router and out to the internet, okay? No problem at all. However, devices within 105 cannot talk to devices in this community here, nor can it talk to anything within the isolated VLAN. So these two can talk just fine, but they can't talk to anything else because the other ones are different communities and a private VLAN, sorry, an isolated VLAN. Now, if we just follow on from that, devices in the community 109 here, okay, they can talk to each other. They can also talk to the router because that's a promiscuous port, but the devices within this cannot talk to the devices in a different community, i.e. they can't talk to these devices, nor can they talk to the devices in the isolated private VLAN, okay? Now, the isolated VLAN, you only need to create one of them because every device that gets put in an isolated VLAN is basically isolated from everything apart from the promiscuous port, okay? So that means that the device here in the private VLAN cannot talk to anything in the community VLAN of 105, it can't talk to anything in the community VLAN of 109, and it can't even talk to other devices within the same VLAN because it's an isolated VLAN. So that means this device here can't even talk to this, they can't see each other, okay? So all this device can do is speak out here and go to the internet. All this device here can do is speak out and go to the internet. Devices in 109 can talk to each other, devices in 105 can talk to each other, but devices in 105 can't talk to 109 and 109 can't talk to 105, okay? Does that make sense? It's a little bit confusing at first, but see, once you do it, it can actually make more sense. So, if we go and do you know what, actually, I'm just going to quickly bring this up because if you are aware of protected ports, you might be thinking all I'm doing is really just giving some kind of port isolation, and you can do that with protected ports. Now you absolutely can, and in the case here which I've got, you could probably do that, okay, because we're using a singular switch here, okay. The difference is, see, with private VLANs you can actually extend this functionality across multiple switches. So if we've got a switch here, switch 1 and switch 2, okay, we can actually do this thing whereby we could put the primary VLAN here and put a community here, pair with a community here across different switches, okay? That's a key functionality, and you can put this one in isolated and this one in isolated, and it's still going to work across different switches. Rather than just using port isolation via protected ports, you're going to be limited to a single switch. Now, in the example which I'm using here, I'm only using a single switch to keep the configuration as simple as possible, but just be aware of that difference in functionality, okay? So with that said, what I think we should do really is go on and just do some basic configurations and then wrap the video, because there really isn't too much more private VLANs than what I've said. There's a little bit of a few wrinkles, but not much. So I think the best thing to do is just to go on and do the configuration and just let you see how each secondary VLAN maps to the primary VLAN, and we'll do some ping testing towards the end and see if we've got the right outcome which we seek to achieve effectively. Okay, so let's go and do it. And just to give some context here, if you notice the actual way I've laid this out, I'll actually just pull this up quickly, is that just this. The scenario here which I've got is I'm imagining that, now okay, I know I'm using private IP addressing, but let's say it's the public address space and these are all servers reachable from the internet, okay? Now, what we've done is we have got VLAN 100, which would be a server VLAN, okay, but we've actually used private VLANs to isolate those servers from each other in certain ways. So let's say we've got a public email server, okay? There's no real reason for that to talk to any other server, okay? We just want that to be isolated on its own, so we've put that in the isolated private VLAN. Same with the web server. Doesn't need to talk to anything else but itself effectively, so we've got that in the isolated VLAN. That means the email and web server cannot talk to each other, okay? Similarly, over here, we've got DNS, okay? Now, we don't want the DNS to talk directly to the web or the email. We do want them to be able to speak to each other for functionality of replication and so on, for ability update. So we want them to have communication, so they're within the same community. That means that they two can talk to each other and out to the internet, but nothing else. And like I say, devices within isolated VLAN can't talk to anything else. Now, if you think about this, what does this really mean? Let's just say that we had a hacker, okay? Let's just be really dramatic and say a hacker comes in and he somehow finds an exploit in the email server, okay? Now, if he gets into the email server and he's got an exploit and he's somehow got a reverse shell or something like that, what he could potentially do is pivot to different devices on that network. So he may be able to, from there, get into the web server and into the DNS server quite easily, okay? By providing this isolation, if he finds an exploit into the email server, we're pretty much chaining him down just to there. He can't really pivot and get into different services, okay? So that's kind of the logic behind that. We're grouping things together, so the things that can talk together are only talking because they have to. If they don't need to talk, we're trying to isolate them as much as possible to provide that extra layer of security. So that's really the logic behind what we're doing. So let's just go and pull up the switch and do the configuration. Okay, so let's just go to the switch. Now, the first thing to note is that when you're configuring private VLANs, because of VTP version 1 and VTP version 2, they do not understand private VLANs, so it's important to set your actual VTP mode to transparent. So let's do that first. Okay. Now, what I'm going to first do is create the secondary VLANs, which means VLAN 110, which is going to act as our isolated VLAN, and VLAN 105, which is going to act as our community VLAN. Okay, so let's just go and create them first. So the way to do that is pretty simple. VLAN 110 and private VLAN isolated. That's the mode it's going to be. So if I put a port in VLAN 110, it's going to act as an isolated port, okay? If we go out here and do VLAN 105 and do private VLAN, and if you put it in VLAN 105, it's going to be a community, and that's that. The next thing we need to do is create the primary VLAN, okay? So that is VLAN 100, so let's just go and do that. And we do private, oh, if I can type John Boy. And that's that. So what I need to do next is do, because we're in VLAN 100, we're going to do private VLAN and associate this primary VLAN with the two secondary VLANs of 110 and 105, okay? So what we're going to do is do 105, 110. So that means that VLAN 100, the primary VLAN, is going to associate itself with these two sub VLANs, okay? 105 and 110, and that's that done. So what I need to do now is actually configure each port to be a member of their respective private VLANs. In the case of the ones on the left, 100.1 and 100.2, they are going to go into VLAN 110, which means they're going to be isolated from everything, bar effectively the gateway to the internet and internet itself. Okay, they can't talk to any other devices attached to this switch. On the right hand side, we're going to have the community VLAN, which is devices 100.3 and 100.4. They can talk to each other as well as the gateway to talk to the internet, but they can't talk to anything within the isolated VLAN. Okay, so we've got gig 01 and gig 02 in VLAN 110. Let's go and configure them first. Now, this is pretty straightforward. So we do int gig 01, and you'll be seeing this command before, switch port modes. But if you actually notice, there's actually just not access and trunk and whatnot. We've got this set in private VLAN, and that's all we're going to explore. And it's going to be a private VLAN host. Okay, and that's us. So we've made it a private VLAN host. What we also need to do is tell it what actual host we are. So we're doing host association. And remember, the first thing we need to do is tell it what primary VLAN we're a member of, because we're still a member of VLAN 100. So that's the first one you put here. And you'll notice that context sensitive help actually gives you a little bit of a clue here. It does say to highlight the primary one. Okay, so the primary one is 100. Okay, and the private VLAN membership we want is, in this case, is 110. This is the isolated one. So that's that. And if we just do the same for gig 02, we do switch port mode, private VLAN host, switch port, private VLAN host association, member of VLAN 100 as a primary, and within VLAN 100 we're going to be a member of VLAN 110, the isolated private VLAN. And that's that done. So we've configured our isolated ports. Let's go and configure the community ports so they can talk to each other within VLAN 105. So if we go to gig 03 and gig 03, and we do switch port mode private VLAN host, switch port private VLAN host association, VLAN 100, remember the first one, and the VLAN within that we're going to be VLAN 105 this time, which means we're going to be the community. Okay, and the last one is int gig 10, that should be, switch port mode private VLAN host, switch port private VLAN host association, VLAN 100, and within VLAN 100 we're in 105. Okay, so that's that for the actual hosts. Now what I want to just kind of highlight here is that often in configuration examples you will see that this actual device, okay, this might be configured to be attached to a router or something like that, and we're not going to have an SVI here, which is what I'm actually going to do in this configuration. If you're not doing it on the SVI, you're going to configure this port here, gig 00, to be in the mode of promiscuous. That means that device here, for example, can talk to that port, and that means it can get out to the router and therefore the internet. Okay, so that's the way you would configure it. You'd create this actual configuration on gig 00, the physical port. In this case, I'm doing it on the SVI, so it's going to look a little bit different, but the net effect is it's going to be the exact same effect. Okay, so if we now go into interface VLAN 100 and we do IP address and give it the last address 254, okay, and we'll no shut that. Now what we're going to do here is do a private VLAN, okay, and we're going to map interface VLAN 100, we're going to map it to VLANs 110 and 105. Those are the private VLANs within the primary VLAN, okay? So that's that. In doing so, we've effectively made interface VLAN 100 promiscuous, okay? You don't actually take the promiscuous command on SVI, you do that on physical configurations, but the net effect is now the same. So what I'm going to do is do some testing to see if the configurations took and are acting as expected. Okay, so I've actually pre-configured these IP addresses on the end devices, the email, web and DNS servers. The first one I'll go to will be the one on the right here, which is 100.3. This is part of the community VLAN 105, which means that it should be able to ping the other DNS server and the internet, but nothing else. So let's go and try that. So we do a show IP, you can see we've got 100.3 and our gateway is 254, which is the interface. The SVI we configured is effectively promiscuous by mapping it to the private VLANs. So if I just ping myself first, just to make sure the stack's working fine, you'll see that's fine, okay? We can ping ourselves. Let's try and ping 100.4, which is in the same community private VLAN. We should be able to ping this. And you see we can, okay? So we can ping ourselves, we can ping a device within the same community private VLAN. Let's try and ping 101 and 102. They are in an isolated private VLAN. We should not have connectivity. We should not be able to reach them at all. So 100.1. See, not reachable. 100.2. Same again, not reachable, but let's try and ping our gateway. We should be able to see that because, like I say, that should be effectively acting as promiscuous and can talk to everything. We can ping that. And let's just try and ping. Do you know what, I'll just quickly just... So we can ping the internet as well. We can ping 8.8.8.8, which is fine. Let's go to this one here. Again, so we do a show IP, ping ourselves, 192.100.4. Let's try 100.3, which is the same community VLAN, private VLAN, so we should be able to ping this. Like I say, and we can, which is all good. Same again, let's try to ping the isolated one. Should not be able to do so, should be unreachable. Good. We can't access the email server from the DNS server. Let's try to ping the web server. Good. We can't access the web server as well. And if we ping 100.254, which is our gateway, again effectively configured as promiscuous, we can also ping that. Therefore, we can ping the gateway. Therefore, we can ping the internet. So we can try to ping the outside world. So we can reach the outside world. Okay. Let's go to this one here, the email server, show IP, we're 100.1, let's ping ourselves. 100.1, we can do that. Now let's try and ping, like I say, 100.3, we should probably know the result of this already. Unreachable. And here's the question, okay, 100.2, this is in the same private VLAN, okay, but because it's an isolated private VLAN, it should not even allow the communication between these devices, so the email should not be able to ping the web server. So let's check this, and this should fail also. Yep, so even because they're in the same private VLAN, because it's actually configured to be an isolated private VLAN, it's acting in a way such that we have total separation and isolation. But like I say, we should still be able to ping the promiscuous port, which is interface VLAN 100, which is our gateway, and we can ping that, which means that we can also ping out to the internet, so we can still reach the internet. There we go. Yeah, so I mean that's pretty much it. Private VLANs, to recap, they give you that port isolation over multiple switches rather than just configuring protected ports. They're typically seen in the service provider world when you need to logically separate or group together customers. They're also seen in DMZs when you need to separate services, and that's pretty much it. It's quite a simple configuration, but sometimes it takes a little bit of repetition just to get it all straight in your head. So I will say the best thing to do, like always, is to lab this out and you'll get it quite easily. Okie doke, so that's the end of the video. I plan to make a lot more videos more frequently, like I say, because my exams are now over, I've got a bit more free time. I think the next one I'm going to do is do a little bit more on network automation again. I've been really enjoying Pi ATS and Genie, and I think that'll probably be the next one before we wrap up for the CCNP Switch series. Okie doke, so that's it. Thanks very much, and I'll see you guys soon. Bye bye.